Hello, today we are going to start our unit on trigonometry. So, a lot of my students say, oh, trigonometry, I can't do that. Trigonometry is the study of right triangles. All of us know what right triangles are, so surely we can do that. We're going to start with the tangent ratio, and then we'll go to sine and cosine ratios. Remember what the word ratio means? Fractions, yes. So, I'm learning to apply the trigonometric ratios to find missing measures. Pause the video and do the warm-up. This is using the geometric mean. Find x and find all the missing measures. Pause the video and do the warm-up now. Well, I do hope you tried. So the first thing I'm going to do, I need to find a second leg on this triangle. So I'm going to call this y. If you remember about the geometric mean, 20 over x, my short side over my long side, equals my short side over my long side, y over 25. Okay. Short side, long side. When I go to the other triangle, long side, or short side, long side. Now we can solve. We will do the cross multiplication. We know that y times y will be y squared is equal to 20 times 25. Y squared is equal to 20 times 25 gives me 500. The opposite of squaring is taking the square root. The square root of 500 is 22.36. We're going to round it to the nearest hundred. Now, we know two of the three sides. Whose theorem do we use? If you said the Pythagorean theorem, you would be correct. So, to find x, we know that these are our two legs. So, x squared is equal to 25 squared plus 22.36 squared. The opposite of squaring? Square rooting. And we're going to put it into the calculator all at once. The square root of 25 squared plus 22.36 squared, and I end up with about 33.54. Okay, move that over a little bit. So, if I'm looking, I can use that big triangle, or I can use the smaller triangle. I'm looking for the hypotenuse here, so I think I'll use the smaller triangle. So, if I call this z, the z squared will be equal to 20 squared plus 22.36 squared. The opposite of squaring is square rooting. and we end up with 29.999. That is about 30. And that would be 0.00. Because remember, we're going out to the nearest hundredth. So, as you're looking at this, this is the way it works. Your trigonometric ratios work only with right triangles. You have to know the difference between your adjacent leg, your adjacent side, your opposite leg, and your hypotenuse. Hopefully you all realize that your hypotenuse is directly across from your right angle. So the trigonometric ratio we usually start with first because it is the one that does not use the hypotenuse at all. Your tangent ratio is the length of the opposite side over the length of the adjacent side. So we shorten it down. Tangent, tan is opposite over adjacent. Your sine ratio. Once again, you're going to use the opposite side. So it's the length of the opposite side. This time, instead of the adjacent side, we're going to use the length of the hypotenuse. Remember, I told you that the tangent was the only one that did not use the hypotenuse. So for the cosine, we've already used the opposite side, so now we have to use the adjacent, the length of the adjacent side. Over the length of the hypotenuse. Okay, so tangent, opposite over adjacent, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse. If you're looking at this, you see that little funny looking circle with a line in the middle? That is the Greek letter theta. What does theta mean? Theta is the variable we use for a missing angle measure. Could we use XYZ? Yeah, we could. But usually for your angle measures, we use theta, beta, and alpha. Where else have you heard theta, beta, and alpha? Think of your colleges. Those are the sorority and fraternities. They use Greek letters also. So, now we have to explain what an adjacent side is. What is an adjacent side? So to be able to define adjacent side, we have to think of what the word adjacent means. Adjacent means next to. The adjacent side is the leg that is part of the angle you're looking at. So if you look up here, this is adjacent. See how it goes into our angle theta. So the opposite side is the leg that is not part of the angle. And that would be over here. And that leads us to the hypotenuse. The hypotenuse is the longest side across from the right angle. So if you look, your hypotenuse is straight across from your right angle. So we're going to look, what you're going to find out is that when we work with fractions, we always have to simplify them if possible. So as we're looking at the tangent ratio, we're looking at a fraction, and we have to think about simplifying. So if I'm looking at x, the tangent of x, here's x, opposite leg, opposite is 28. Adjacent leg, 21. They both have a factor of 7. 28 divided by 7 is 4. 21 divided by 7 is 3. So that is the fraction 4 over 3. But what happens if we go to angle Z, the tangent of Z? This time our opposite is 21 and our adjacent is 28. You notice we just totally ignore our hypotenuse. Your tangents, depending on which angle you're looking at, will be your opposite side and your adjacent side. But your two tangents will always be reciprocals. So this is 3 over 4. Okay, what about the next one? If I'm looking at the tangent of A, I'm down here. Straight across is 36. Attached to it is 27. Both of these have a factor of 9. 36 divided by 9 is 4. 27 divided by 9 is 3. Can you do the tangent of C? Can you pause the video and do the tangent of C? Well, I do hope you try it on your own. Here's C, straight across is 27. Attached to it is 36. If you remembered me telling you that they would be reciprocals, you didn't even have to look. You just flip this fraction upside down. And now we get 3 over 4. Okay, one of the reasons that the trigonometric ratios are so handy is that you can use them and use indirect measurement. And then you can find measures of things you cannot measure by standing beside them. Katie is looking at the Washington Monument located in Washington, D.C. The monument is 555 feet tall. From where she is standing, the angle made between the ground and the top of the monument is 75 degrees. How far is she away from the monument? So if we're looking at this, this will be X, and this is our angle. That we're using. So this is opposite, this will be adjacent. Let's set our equation up. Before we did not have a numerical value for our angle. This time we do. So the tangent of 75 degrees is equal to 555 divided by X. Any questions? This is where the angle measure goes. Okay, now let's solve. Remember, this is a number. So the first thing I'm going to do is to multiply both sides by X. X times the tangent of 75 degrees is equal to 555 feet. Okay, I need to get the X by itself. What am I going to do? I'm going to divide by the tangent of 75 degrees. Remember, the opposite of multiplying is dividing, so the tangent of 75 divided by the tangent of 75 would give me 1. 1 times X is X. So when you get ready to use your calculators, the first thing you have to do is to go into your mode. Your mode button is right here. I need to make sure I am in degree mode. If you're not in degree mode, you'll get really weird answers. There's 2 ways of measuring degrees. We can measure them in radians, or we can measure them in degrees. We always have to be in degrees for using it with our trigonometric ratios. Okay, so now where's the tangent button? If you look, here's sine, cosine, and tangent. So I'm going to take 555 divided by, here's my tangent. Now I plug in 75, close it, and I end up with 148.71. We would probably just simplify to 148.7. So what does it mean? It means she is about 148.7 feet from the monument. Okay, now, to find the measure of an angle, you use the inverse button, the second button, and then the tangent. So if I'm looking at the tangent of Z, the tangent of Z is If I'm up here, 24 over 32. The measure of angle Z, I will put, whoops, I've already got that over here. I didn't see that. So what I'm going to do, I do not need to simplify it because I'm not looking at the ratio. I'm looking at the degree measure. So in my calculator, second tangent, see how you get tangent to the -1 degree. Then I type in 24 divided by 32, close it off, and I get 36.86. That would be approximately 36.9. We go to the nearest tenth on our degree measures. Remember, you use the tangent to the -1 power. Second, then tangent. Okay, what about the next one? Okay, if I'm looking from X, what is my opposite side? 32. What is my adjacent side? 24. Second tangent. Oh, if this is 36.9, there's another way we can find it. What is it? But let's go ahead this way. Second tangent. 32 divided by 24, close it off, and I get 53.1. Okay. Second and tangent gives you that tangent inverse button. That's what gives you your degree measures. If all you're doing is looking for the tangent, you have to simplify that. If I simplify 24 over 32, 8 goes into both of them. 8 goes into 24 3 times, goes into 32 4 times. Let's pretend like I have a rough time simplifying. I will type in 24 divided by 32. Then I will hit my math button. Then I will hit enter, and that tells me I'm going to have a fraction that's simplified. Enter again, and there is my 3/4 also. Remember, it's it's math, and then hit enter twice. Type in your fraction, hit math, and then hit enter twice. Now, I don't need to do it again because these are reciprocals, so this will be 4 over 3. Okay, pause the video and see if you can find the tangent of A and the measure of angle A. Then we'll look at that, and then we'll look at the other one, or do them both at the same time. Pause the video and see if you can do the first one or both of them now. Well, I do hope you tried. If I'm at angle A, 16 is straight across. 16 is my opposite, 30 is my adjacent. Okay, both of those are divisible by 2. 16 divided by 2 is 8. 30 divided by 2 is 15. Now, I have to use my inverse button. Remember that tangent, second, and tangent to get the inverse. 8 divided by 15, close it off, and it is 28.1. What about the tangent of C? What is their relationship again? They are reciprocals. So this becomes 30 divided by 16, which becomes 15 over 8. Now, if one of the angles is 28.1, how else could I find the measure of angle C? If this one's 90, these two have to be 90 also to make 180. So I could take 90 degrees minus 28.1 degrees, or I can still do the second tan, and then it would be 15 divided by 8, and it would be 61.9. 90 minus 28.1 is also 61.9. So whichever way you do that second angle measure will depend on how you want to do it. I've always found it quicker to put in the tangent inverse, the sine inverse, the cosine inverse, whichever inverse you use, and then that fraction as to subtract it from 90 degrees. But either way it's possible. So how do you know when you're successful? When you can apply the trigonometric ratios to find missing measures. This is the tangent ratio, which is your opposite length over your adjacent length. And to find the measure of the angle, you use that tangent to the -1 power.